Hi, Algebra 1. In Lesson 3 here, the unit circle, we're going to be looking at how do you convert between degrees and radians and how to find trig ratios using the unit circle. Here we go. So far, when we've been working with trig functions, we've been using degrees as measuring how much of the circle we're talking about. The other way to measure instead of degrees is using radians, and that's going to be looking at this angle right here, theta. What is that angle when we take the radius and use that as the length along the side of the circle? So when this length, arc length we call it, is the same as the radius, the angle that we're left with is called theta, and that's going to be equal to 1 radian. And we see that if we do this across a circle, we're going to fit one distance of a radius, which is going to be 1 radian. We fit another distance of a radius, which is another radian. We fit a third distance, which is a third radian. And then what we have left right here, that angle is going to be 0.14159 radians. So we end up with 1, 2, 3 plus this radians, which gets us the 3.14159 going on forever radians. And we should recognize that number, that irrational number, as pi. So pi radians is the same as half a circle, 180 degrees. Converting between degrees and radians or radians and degrees is just a simple unit conversion. We're going to be multiplying by our pi radians over 180 or the other way around, depending on what we're looking for. So our first one here, negative 60 degrees, we're going to multiply that by pi radians over 180 degrees. And that's because we want our degrees to cancel essentially, that's our label, and we want to be left with radians. And so that's what we'll get here. And as we multiply, we can simplify. 60 goes into 61, 60 goes into 180 3 times. And I still have this negative here, so I'm left with negative pi over 3 radians. A lot of times we won't put the label on it. You'll see that a lot in your book. If you see anything with just pi over something or 3 pi over 4 or something like that, and there's no label, you can assume that it's radians. In this next one, we're going to convert 2 pi over 3 radians to degrees. So I'm just going to write 2 pi over 3. I'm going to leave off that label in this case, but I am knowing that the radians is right there. That's going to help me decide that I need to have the 180 degrees on top over pi radians in the denominator, because again, we need to be able to cancel that radians label that I didn't write out, and we want to be left with degrees. Now I just simplify before I multiply. My pi's will cancel out. 3 goes into 3 once, 3 goes into 180 60 times. I'm left with 2 times 60 equals 120 degrees. When we talk about the unit circle, what we're referring to is a circle that has a radius of 1. And as we go around the circle, we are able to figure out the sine and cosine values of different degree measurements, specifically 30, 45, 60, 90, and as we keep going, degrees that are going to have a reference angle of 30, 45, 60, or 90, and then their radian measures as well. And we can figure out the sine and cosine of those values very easily using the unit circle. As you use the unit circle, your special right triangles, I put these in here coming from section 1, are going to come into play a lot. And you can kind of think of the unit circle like a dictionary or like a periodic table in chemistry, where it's something that you can always refer to and use to figure out and help you solve problems. The other thing to note, and they're color coded over here for you, is that when we're finding the sine of theta, any angle coming from our origin here, I'm just going to draw a triangle like this. When we're figuring out the sine of theta, sine is opposite over hypotenuse. So this is going to be the opposite is the y value going up and down, and the hypotenuse is your radius of 1. And so sine theta is going to simplify to just y over r, which is y over 1, which is just y, or in other words, the y value of that coordinate point. Similarly with cosine, Cosine is adjacent over hypotenuse. So that's going to be the x value, how far left and right the point is, over r, the hypotenuse, which is 1. And so it simplifies to just x. So the x value of your coordinate point is the cosine of this angle theta. And now tangent is just going to be your y value over your x value. In other words, opposite over adjacent. This is why on the unit circle in your book, the cosine values are blue. They're going right along with this. That's your x value in your coordinate, and the sine value is red. They're going right along with this. The other thing I find helpful is that just like x and y go alphabetical, cosine and sine go alphabetical. So cosine goes first, that's your x value. Sine goes second, that's your y value. When you use the unit circle, you're going to want to remember that you always are going to draw a right triangle that is going to have its right angle on your x-axis. So I'm going to draw this example right here where my right angle is on the x-axis. I can see 30 degrees is written right here. That is the measure of this angle. And then I know, because it's a special right triangle, that it's a 30, 60, 90 right triangle. And so looking down here at my special right triangle, I also know the lengths of these sides. I know that this is going to be 1, that the hypotenuse is going to be 2, and the other side is going to be the square root of 3. Now from here, I can figure out the sine and cosine. So now, using your unit circle and your special right triangles, we can see that the cosine of 30 degrees is going to be the adjacent over the hypotenuse, or square root of 3 over 2, which is the x value of this coordinate right here, the cosine of 30, or the cosine of pi over 6 radians. Those two things are the same. Then the sine of 30 degrees, or sine of pi over 6 radians, same thing, is going to be the opposite over hypotenuse, or 1/2, and that's the y value of your coordinate point.